trying to send some data to your application. Then your application will do the logic, and then any changes that are made can be written to the database, or they can also be sent to a third-party API. So all of this, we're just trying to decouple your business logic. And you can also use this type of thinking. I've heard you guys talking about microservices. You can also use this thinking around microservices. So your microservice should encapsulate only a single business domain. And that's when now we can go through like solid principles. Go back to the, yeah. So in the solid principles, we can see that S, when we are talking about your adapters, your infrastructure, the S here, we can say it's single responsibility. So your database should only do your database operations, your creates, reads, updates, and deletes. You shouldn't do other implementation. Like, let's say if you want to send an SMS, you should create a new service in your infrastructure that specifically sends SMS. So your services should only have one single responsibility to them. That's now the S in the solid. Then O, we can say it's the open-close principle. So since your interface is a contract between APIs, it says if I give you these inputs, you give me this output. That's your agreement. As the Kenyans know, we say ukipewa. Yeah, so that's that's the O. The O stands for you should be open to extension. You should be able to extend your interfaces. If you want to add another new service, you should just add it. You shouldn't modify an existing external service. Then the L, I think, is Liskov's substitution principle. I don't know how you can infer it here, but generally it means that when you're inheriting from something, you should always be able to access the attributes and the methods of the parent class. I don't think we can show it accurately here, but we'll have some code examples. Then we have the interface segregation principle. We'll also show you that in the code examples, and also dependency inversion, we'll show you in the code example. Yeah, so I think you can continue.
All right, thanks for that. So, so the next section is what are the components that I used to build up this architecture. So some of the notable components in this pattern are actors, basically. And actors can be either from the presentation or from the repository, that is either the front end, web, mobile, etc. For the repository, that is databases, that is can be PG, can be Maria, can be Firebase, whichever choice that you make. So, and they are of two types. One, we have, maybe if I take you back to this diagram, we have two types of actors. So we have now the primary, that is the driver actor, whoever initiates the action, like whoever triggers an action from your system. And then the secondary, or rather driven actor, who provides features to your application. These features can be things like maybe reads to your DB, sending mails through mail servers, uploading stuff to third-party services, and such, yeah. So the other key component of this pattern is the ports. Remember we said that the ports are basically interface, the contracts. So basically the ports define, or rather are means of communicating with the external components, such as web UI. So in this case, remember you have already abstracted your business case. So if any component needs to talk to your core business logic, now the business logic has to define how the other actors are supposed to talk to it. That is through the interfaces. So we have there are two types. One, we have just like the adapters, we have the primary ports. Basically, it contains the boundaries. Remember, it's about segregation, right? So it defines the boundaries that the application to an external component, e.g. sign up feature, and as an example. We also have the secondary ports, which defines the features of outside components to the business logic. In the sense that if you have your repository layer, you can have methods, or rather an interface defining You can have features. You can define how your call will talk to the external components. So the other component is adapters. Mike, you want to talk about it?
Yeah. So your adapters are components which connect ports with the external components. So simply we have like two primary adapters. We have, two adapters. We have the primary adapter, which initiates the business logic through the ports, which are the interfaces. We'll show you that in the code examples. I think it's better to learn things visually. And then we have our secondary adapter, which is used to communicate to the outside components, and it's achieved by converting business logic requests to requests understood by the outside component. So simply this means that you can have your interface. Let's say you're talking over REST or gRPC. I like to call it your presentation layer. It can convert the inputs you've received and forward those inputs to your handlers or your adapters to handle the request for you. So I think we can go to the next slide. So I'll leave it to my co-host to continue.
Great. Now, since we have a quick mental picture of what makes up the hexagonal pattern, someone might ask, how do I apply this pattern in my project? So, and we try to simplify these so that we can at least help you implement the pattern in your code base. So we have a couple of questions or other things that you need to consider or to ask yourself before you make that you actually put it into your application. So the first thing is identify what your core business is and put it as a module. Basically, in Go we have packages, and put it in a single, in its own separate module. So that forms the part of your application core. That is where all your business logic should sit. Then the next thing is know who your actors are. Who do you want your core business to interact with? May it be third-party services like mailing services, maybe things like DB. What front end do you expect to use your rather to interact with your business? Is it mobile? Is it gRPC? Is it REST? Whatever. So the third item is ask yourself, what functionalities are available in your system? So, or rather, how do you want, or rather, what is contained in your business case that you might want your actors to invoke from your business rules? So in this case, you define functionalities. Basically, the ports define functionalities that are available in your business case. So the other item that you need to ask yourself is the next thing is now, how do you implement your adapters? So because these are the ones that they sit between the actors and they sit between the port and your core logic. So basically you need to facilitate communication from your actors to your core business logic. So basically that is the sole purpose of adapters. So yeah, I think those are the quick questions that you need to ask yourself before you can actually bring these into your application. So the next thing is that we will demonstrate a very quick demo on how to structure your code. Actually, and before we do that, there is no clear defined way of implementing this pattern, but you just have to kind of choose what sits well with you. But at least what I'm going to show here is something that I personally I have made practical use of it, and it has really helped me for quite some time. So basically, I hope, is it visible? I hope that's clearer. Iko sawa? Okay. So basically, this is our project structure. Allow me to collapse this one. Yeah. So at the top, you can see we have a DB. So this section basically contains migrations most of the times. So, and then that doesn't really matter that much, but there is this section under the package, under the Gophercon package. So you have your application, you have your domain, you have your infrastructure, your presentation layer, your repository, and your use case. So let me translate this back to hexagonal pattern. So your use case basically is your core business logic. So everything, anything that is more, that defines your business logic should sit under this package. And then, allow me to skip this one. We have presentation. Presentation is basically the layers that, or rather, the layer that the actors use to communicate to you. Basically, the entry point of your application. Yeah, let me put it that way. And then we can have, now inside the infrastructure package, we can have, for this simple example, I used two things. So we have the data store and we have your services. Basically, the data store is things like where you define your DB, maybe PG, maybe Mongo, maybe Firebase, Cassandra, whichever DB that you want to use. Then for the services, basically is where you have now integrations to third-party APIs and other services. Yeah. So then we have this section, domain. Now this domain just contains the models, basically models, like vile unataka, oh, sorry for mixing languages, just the way you want your data objects to look like. Basically your structs, they are defined here. And then in the application package, Mike can tell us what.
So the application is usually simple. This is where you store things which are common to your application. So for example, your enums, your utility functions, any extensions that you need for your application to run. It's mostly used to store things which are common to your application that you can't put in the other layers. The main important part here, I'd say, about the presentation layer, you can define all implementations here. Like you can have REST APIs here, GraphQL, gRPC, all of your, where your data is coming, where your driver is interacting. Then then inside in the rest, you can have your handlers. So your handlers, they take in the information. Like in here, we made one which creates a user. So it knows that you should receive data which looks like, which has this information in a struct, an ID, a username, first name, last name. Then after that, it will inject it into your use case, which is this create user. So from here, so this use case, it doesn't know about anything to do with the infrastructure. It knows that it doesn't care about what DB you're using, what SMS service you're using, any external APIs. All it does, it knows is I create a user, and if you want me to create a user, you give me some context, and you give me a user object which represents our domain object. And it will return to you either the user and an error. If the error is nil, the user has been created. If there's an error, it will bubble up the error. So that's simply it. We'll post the link to this. You can use it as a template of how you can structure. There is no right way to structure it, but this is how we've learned how to structure our code when we want to use the hexagonal architecture. And another thing we haven't even delved to is how easy it is to test when you use this. Because all we now do, we just need to mock this function, create user, and we can test how other actors interact with our use cases. Yeah.
Basically, to summarize, rather, you remember we mentioned something on ports, adapters, basically ports and adapters. So in this case, our business case here, which is we basically want to create a user. So here you can Maybe as you're creating the user, you might need to perform other business-related logics here and such. But now, if your actor, in this case, which is your front end, can be mobile or REST or whichever, this use case basically defines this interface here, which now acts as your port. So any other client or rather any other actor, they basically need to invoke this method and basically, and then the use case just will figure out that, yes, since I've been invoked from this other end, I just need to just create a user, period. Like all those other external components, they do not really need to know what happens. It doesn't really need to know what your core business logics or your core business rules are. Doesn't really matter to them. Yeah, and then let me show you for the lower level. So that is how to interact with your DB and stuff. So we have this one here. So you have this interface here. Basically, we have create user. It's just a simple one. So this one now defines how your repository services, or rather how external components that need to talk to your business logic, how they will talk, or rather how they will do the communications to your business logic. So in this case, this method will be implemented under infrastructure. We have data store. Yeah, you will find an implementation of that method here. So this basically now acts as your secondary adapter, which invokes now the database actions and such. Yeah.
Yeah. So remember when you were saying solid, this is a classic example of dependency inversion. So your high-level module, which was your use case, knows that if you want to create a user, I just need to pass on the context and the user domain object. It doesn't care how you implement this. So if you were to switch the DB to Firebase, we could write some other implementation of how we can insert our user into a database. But at the end of the day, our use case just knows, if I give this infrastructure, this DB, a context and a user, it will create for me everything. So you might ask, in your professional career, how this can help you. You can easily swap out services without refactoring a lot of code. Just maintain the contract. Give me a context and I'll do this and this and this for you. And you can easily swipe out components. So in your professional career, you'll meet, like, let's say you have some business case where, let me use like an example we've personally had. You can, let's say, have a contract with Safaricom to send in text messages and use them for a while, then you get a better deal and you have to swap. So instead of going everywhere refactoring out the way you used to send SMSs with Safaricom, you can just come and refactor inside where you've implemented the functionality for sending, and things will remain as is, as long as the contract remains the same. So that's simply how hexagonal works. You just have to maintain your whole interface, and your business logic can work as it is, and it doesn't care about any external dependencies and APIs. Yeah.
Yeah, thanks for that. And I think that brings us to the end of our presentation.